Did anyone present on broadcast already?
I didn't, but I can see now that I just got the notification the webinar is live.
Yeah, exactly. Someone pressed on it. It's okay. Hi everyone, thank you so much for joining in. We're just starting off, so thank you so much for joining in a little early. And we'll just wait for another 10 minutes before we begin. So, yeah. Till then, please do let us know where you're joining in from. Maybe let us know um, on the chat. Just click on all panelists and attendees and let us know where you're joining in from. We would love to know. Great to know, Raquel, you joining us from Austin, Texas. And it's great to know you guys still have power. And thank you so much for joining us. We also have people from, we have a lot of people from the US. Um, and do remember to click on all panelists and attendees such that everyone can then see your message and know where you're joining in from. Or it'll only go to the panelist.
Okay, so we have 16 people by now, and it's really nice to see people from all over the world. So we have people from Malaysia, tons from the US, and yeah, tell us where you're from, guys. Post on the chat. Make sure to tag, make sure to make the chat to all panelists and attendees, and tell us where you're joining in from. And we'll be starting in a few minutes. So we're just waiting for some more people to join.
Yeah.
Hi, Annie. Great. So you're joining from Washington, Florida, California. Interesting. You know, the best part about communities like Women Who Code is that we get to see people from all over the world coming together for like one specific thing. sometimes a really specific thing like SQL with Python. So it's always such a pleasure to see people from all over.
Yes, agree. Hi, everyone. Are you guys excited to learn more? Is this your first time joining this webinar, or you guys like had fun with us last week? I mean, the last section. Oh, first time. Welcome, Vanessa. Welcome. Just a quickly reminder, remember to set the chat to panelists and attendees, because I see you, some of you only talking to us. We want to share the beautiful message to everyone. So remember to change the settings. And for those of you who just joining, welcome, and remember to first of all, open the chat, join us, get ready to have a cup of coffee, like, you know, relax, sit down, doing doing yoga. Also, if you have any questions, especially like technical content specific, remember to use the button next to the chat, which is the Q&A, to post your question there. In case, because sometimes like as presenters don't get to see the questions, because like by the time we look at the chat, it's all gone. So like it's good to us, good for all of us to like keep like stays neat and then keep other questions there. First time, woohoo! Excited. Thank you, Ashita. Love to have you back as well.
We actually have a question in the Q&A. So Annie is asking, where can we find the slides? So you will find the slides in a GitHub link. So where the repository has been set up and everything, the slides for the first and the second session, as well as the code content that we'll be doing. So you can find those in a GitHub link. That link will be available, I think, it will be available after the session. So yeah.
Guys, final reminder, just a final reminder, if in case some of you only came in just now, welcome. If you came in, like if this is the second time you joined us because it's the second section, welcome back. Two quick things. Remember to set on the chat before you type a message, remember to set the settings to all panelists and attendees instead of just sharing the happy message to us, so that everyone can see, everyone can join, and everyone can have a nice, exciting day. Especially when everyone is very engaging. If you have any specific question, content related, especially remember to use the Q&A button to answer, to post to post your question there, so that us presenters can see, also the attendee know, other people can know, oh, this question has been asked already, so I don't have to ask again, in case they didn't see it on the chat.
Oh, so Sandra from Nigeria saying it's midnight, it's 12:03. Same here. I'm currently in Germany, so we're in the same time zone. And yeah, it's midnight here as well. So thank you for joining at such a late hour. We're really happy.
Yes, yes, yes. Thank you for joining us before you go to bed. It's
Let's hope we don't put
actually,
you to sleep.
pardon?
Yeah, late night coders.
Woohoo. Shall we start? Hello?
Yeah.
Oh,
Okay.
Ramya, would you want to start?
Yeah. Hello, everyone. Thank you for joining today's session. As mentioned, please let us know in the chat where you're all joining from. My name is Ramya. I'm one of the contributors to this series, and I will be moderating for today's session. And who we are a Women Who Code organization, Python track. And today's session is Sqlite with Python. As mentioned before, sorry, we can find the GitHub link here for the slides and our social media and event sessions here. And please make sure your chat is set to all panelists and attendees, and some of the housekeeping rules. Everyone will be muted throughout the webinar. Please share your thoughts on the chats and ask any questions in the Q&A. And our team is here. Please reach out to us for any technical questions you have. And this is our team. Yeah, our mission is inspiring women to excel in technology careers. Our vision is a world where women are representative as technical executives, founders, VCs, board members, and software engineers. Our target is engineers with 2 or more years of experience looking for support and resources to strengthen their influence and level up in their careers. And this is our code of conduct. Women Who Code, an inclusive community dedicated to providing an empowering experience for everyone who participates in our community. And we do not tolerate any harassment of any members in any form. And you can find the full version and report from this link. And this is our statistics about our organization. We have 250,000 and more members, spanning in 95 cities and 122 countries with over 70 networks, and having 10,000 more events, 1,025 daily conference tickets of worth $1,025 and $2 million scholarships. And we have access to jobs and resources. And our movement, as the world changes, we can be connecting force that creates a sense of belonging while the world is being asked to isolate. And a thank you to all our leaders and volunteers for this series. It would not have been possible without everyone's contribution. Now I will hand it over to Karen and Hala for presenting slides following live coding demo. And thank you, everyone.
Thanks, Ramya. Hi, I'm Karen. I will be, so today we have 2 parts. We have the content part and we have the live coding part. Excited, woohoo! Sorry, it's 7 a.m. in the morning. I will be, so we will go through some technical contents first, and then prep you guys for the live coding section. So if you have any questions, feel free to let us know on the Q&A. So we will answer along the way. So we will, because this is the second section, we will be doing some recap for the first section. And then last session, since majority of you is the first time joiner, we talk a little bit about SQL, more for database with fundamentals. And then with this session, we'll talk about more about SQL to prep everyone to get to the coding. We will be using Sql Lite for this section. So we'll do a quick introduction as well and go to the syntax. And the funny, exciting things is like, because this is Women Who Code Python track, so we'll be doing SQLite with Python. So is it, in case this is the first time, like you doing either SQLite and Python, do let us know. We want you to have a good experience, and we'd love to help you as well. Okay, so a bit about section 1. So section 1 would basically talk about two main things: database and SQL. So why is data into database? Database is the perfect way to store a nice organized, neat data. So that's why we need a database. And we usually talk about, we were focusing on relational database management system. So every database is managed in a management system. So you heard a lot of like database, and majority of the time they're referring to the management system itself. So for example, we have there are different kinds of database management system. Relational one is like the data is stored in a table format. So one table, neat and tidy. And the good thing, why is it popular, is because each table has a key, has a common field, the link from each other. So we can store a lot of information in different table, but then we can also like pull them together at the same time if we know the common field. So in order to do a database, in order to sort things out in database, we have a language. We literally have a language, what's called structured query language. SQL is a very commonly used, is the most popular to use to communicate the database. So more about SQL. So SQL is literally very multicultural. It's widely accepted everywhere. Because of that, it has its own dialect. Why? Because database can be built from different people. So for example, Oracle, Microsoft, IBM, or you can name it. They different vendors building their own database systems, and then therefore, like when it comes to communicating with them using SQL, they have a slightly different dialect, like slightly different syntax as well. But the fact that the thing is that they all based on the fundamental structure of SQL. So I posted some example. You probably heard of it. It's okay, you don't know what it is. It's really just one of the variations, a slight variation from the SQL itself. So if you know SQL, you should be able to like do like majority like of these dialects of SQL. So of course, like SQLite is one of them. So we will be talking a little bit more later on. So one thing we want to talk about, we want to let you know is SQL and NoSQL. So in case you knew, you may heard of something called NoSQL before, I just want to let you guys know, just want to do a quick introduction. You guys don't have, this is like a 101, so don't try to like remember everything. But we want to give you guys overview what it is, because it's important. So today we're doing SQL Lite, but on the next two sessions, we'll be doing Firebase and MongoDB, and they are actually all NoSQL. But don't freak out. Let's just get through it step by step, and then Ramya and Hala will be talking more about that on the next two sessions. So why is it so? What's the main difference between that? Like what is NoSQL? SQS is confusing already. What? So SQL is designed for relational database, so our DBMS, where NoSQL is designed for non-relational. It's like the database has no relation to each other. So SQL is very fixed. It's like has a fixed schema, fixed like that. Like everything has to be neat in the table structure, with a standard format. So therefore, the data is very, very structured. So it's very organized and neat. So you have a nice closet. Is because of its neat structure. It has like a vertical scaling, which means if you want to scale it, you want to scale up, you want to like make it more powerful, like you just have to add a CPU. You just have to like add up your, for example, you have a one server database, and then you want, oh, I need more data. I need more, like I need to store more data. All you have to do is to power up the CPU, power up your hardware, and then you can just go all very, very, very deep and then still able to find the data in a very neat and nice way. But then on the other hand, NoSQL is basically complement the not like the little bit disadvantage of SQL. First of all, not everything is neat and tidy, like my closet. Try to, but this is not possible all the time. So that's why NoSQL is very flexible in many different ways. It can be stored. It can be like go through in document type, key value, and graph. It's very dynamic. It doesn't need a very structured data. Therefore, because of its flexibility, you can actually access it, like grow it in a horizontal way, which is like a multiple. Like you can access to like multiple resources. Like it's need to be neat and structured, because like SQL, everything needs to be neat in order to run. But SQL or NoSQL, you can install it in document format, JSON format, and XML format. If you heard of it, it's very flexible. But we will talk about this. I believe we will talk about this like in the next two sections. So there's a CLUD operation on SQL. It's not just SQL. It's just like a computer programming language in general. Basically the four fundamental functions for data storage. Just like give you guys a little like information like what is where. So like we have like create, read, update, and delete. Four basic things. For equivalent for SQL, equivalent is the insert, select, update, and delete. Now it could be a little bit different variation. Sometimes as far as I know, everybody uses this fundamental structure, but there are a little bit, like I said before, there are the dialects, so it could be a little different. It could be something like just slightly different, but like they all using the same function, same fundamental, the four functions. So before you get into data, before you get into SQL, any programming language, you need to know the data structure, especially database. Before you get to know SQL, you really need to know the database really well. How is it stored? Where's the store? So SQL Lite, interestingly, I just learned it when I'm doing this, has like 5 main types of data types. Then of course they have like subcategory, for example, like text, like char and char. If you have heard of it, it's basically stand for character and variation character. It's all under the category text. So that's the example, like they have like subcategories, but like the main type is string, text, null value, like nothing, nada. Integer, 1, 2, 3, 4, 5 as numbers we know most familiar with. Real number is the float basically, so it has the decimal. So, and then blob is how the data is stored exactly as it was input. So like it's the good thing about like having the structure is when you pull out something in a very large database, like there's a specific like way to pull it out. For example, text, you need a quote. Sorry, it should be a single quote there. I typed it wrong. So if you need a single quote to represent a text / string. Integer, you can just you just type strictly to the number. For example, something like that. So it's very, when it comes to like if you do a very complex statement where you could convert SQL script, like that becomes very handy. So what about, okay, now I have 5 things, but what about the dates? We like to store dates. Dates is important in everything, like everything. Datetime is actually a built-in function on Sqlite in this sample. So basically it is stored in text, real, or integer, as you can like think about it and name it. So it's just like whether you know datetime is not a data type, it's actually a built-in function that you can go, like you can understand more about it. If you want to understand more about it, like just go to SQLite and then type date, and then you can read how they store different types of datetime and date formats. Okay, now we're gonna go into, now that I shuffle you guys a bit more about the SQL, let's go to SQL Lite. So SQL Lite, like I said, mentioned before, it is a relational database management system. Our DBMS is designed for, the syntax is designed for that as well. It's a very light, so the good thing about SQL Lite is it's very independent, self-contained. It doesn't need a server. You don't need to connect to a client in order to create a database or to act on it. It's a very lightweight software library. It's very dependent, which means you don't need much dependency on. If you come from another programming background, there are languages and there are some software that's highly dependent on something, like has to depend on a software or specific software or operating system. But this is not. For example, Microsoft Access, Microsoft SQL Server. It could be independent in a way, but we all know it needs to have a Microsoft license with Microsoft Access in order to do Microsoft SQL Server. So that's the good thing about SQLite. It does also, sometimes there are server that's the DBMS that is restricted for operation system, but in this case it's none. I can use, like, for example, I'm using Linux right now. I can definitely use operating system, and you use Windows or Mac, that's no problem. We sometimes take it for granted, but of the convenience, but like that's just wanted to aware this SQLite and one like other like DBMS is very, very convenient compared to other very strict like as like Oracle or IBM. So in case you missed the last section, it's just the very first time you're coming here, we want to go through some very like a syntax sample. We have 4 different things. So for example, last section, we Hala was showing explain like how do we design a database. So for example, like we talk about bank, we want to build something from we want to build a database for bank. So like the basic two table you need is a client and an employee. So we want to know what client like you have, obviously, and you want to know what employee has like deal with it, like deal with like each client. So for example, if you open a bank account, you have like you want your employee enter all the information for like for example like first name, last name, age, and also like who dealt with the employee, which employee is dealt with them. And then you have another table because you don't want to store everything at once. You have another table which each employee is represented as a number. We want to know we want to know more about the employee as well. So we have like other information stored there. So for example, if we want to I think Hala will be probably going more deep, like a more practical hands-on bit to that. So don't worry if you don't understand. So it's just an example, like I want to find the client's last name and first name, and I just want to like select the field I want, use it to select syntax from the client. The join table is actually not needed, but like I just kind of show it for the for this, like, oh, it could be done like this. So basically from a client table, join the employee table on the common field. It's just the foreign key in this case. Employee ID. So you join the two tables together and you can pull out more information about this. And then you sort it in where I want to know the last name is Smith. And then in case they are like James Smith, Peter Smith, John Smith, like you can name it. And then you just, you want to sort in age, for example. Because maybe there's a very young John Smith, like because John Smith is a very common name. You want to that John Smith is young, so you want to sort it by age so that like you can find the John Smith faster. So that's the basic syntax and the Python. So with the big this is how we dealt with an SQL Lite on the app on the database management system. SQL Lite is one of them. Python, it can actually associate with Python. Python is a very it's one of the language that you can easily interpret and interact with other language as well. I mean, all programming language has this common thing that you can interact with for sure. But Python is very, very well used because it's very easy to build on. And it's and then you just have to import the library and then import the library and then use the functions within the library. For example, we want to do the exact same syntax on the last slide with Python. So just show you a quick demo. How to do it is basically you have to first import the library. In Python, you always have to import the library first if you want to use a function, which is majority of time, 95% of time. And then first, what you didn't know is you had a connect function. So before you start typing the syntax, the moment you open the software is where you're connecting, or you clicking, you have to connect to your database. Sometimes it's automatically connected if you are not the first time doing the database, and then there are times you need to connect it at the first time. And then you connect to the database, and then you move your cursor, you move your mouse to certain things, to certain area, and then start typing the SQL. Sorry, then finished over there. So basically you type the exact syntax. No, it doesn't, comma needs to be there. It doesn't need to be a new line, but it's just a comma and the space. It needs to be there. So you type the exact same syntax there, and then you call the syntax, and then now, and then for the fourth one is when the table shows. So picture you going to a software, you type the syntax, and then usually below the table shows. So the for here is where the table shows, like for row in cursor, where we execute that's the T code statement. We want to print the data, we want to print the rows and like nice and neatly. So after we fill the table, you usually close the app, right? So we need to do connect close in a close connection. It's a good habit. It's definitely a good habit to close the connection. It's actually is necessary, because once you connect it, sometimes it could, like when you you could like, it could potentially like corrupt the file, or like there's something on and then you run it and then you, without you knowing, and like, you know, that's not necessary. So once we open, we close it. Same with other, same with opening another file, like a CSV file. So, and then now I pass to Hala. Hala, do you think we need 5 minutes for everyone, or like you wanna keep going with that?
I don't mind either way. We can take 5 minutes. That's fine.
Do you guys need 5 minutes to process, to get ready, or you guys want to keep going with this?
Okay, let's take
All right. Okay, let's take a 5 minutes break.
Okay.
If you guys have anything, let us know. And then we will be back in 5 minutes. It should be.
No, you don't need to load anything from the first session. So I'll be doing some live coding, and the codes will be available online after the session. So yeah. Yeah, okay. The course isn't actually on GitHub. It will be after. It's still on my personal GitHub, but it's not on the Women Who Code Python GitHub. So you'll find it after the event. Good question. You actually do need to install the Sqlite DB Browser separately. It does not come with Python installation. The library for Sqlite 3, it does come with Python, but the actual Sqlite software, you could say, no, you have to install it separately. If you're interested in installing it and sort of maybe following along, or just wanting to look at the UI, I can type in a link. So here we go. So you can find the relative release for your specific OS, so maybe Windows or Mac OS, and then download it, and the standard installing. So there's nothing really there's nothing new there, but it's not a necessity. So this is just if you're interested and motivated.
I really have a good point. Good pointing out. You actually right. So Irina's question is like, Irina's like the comment is like, for the row in cursor right here. I confused you guys. I apologize. So the print statement only have print row instead of like the 4 rows, like 1, 2, 3, 4. I was trying to do something, but like basically like because we have 4 fields, so we it's like you just need to print row instead. But if you want something very specific, like for example, after you fill out all the data, after you select all the fields, and you want to just specific stuff, you want to like specific field from that select field. I know it's confusing. You can do that, but yes, Irina, you're right. You just have to do for row in cursor and print rows, and this should show you all the lines.
Yeah. We also have a question, what is the difference between MySQL and Sqlite? They are just different database management systems. So like we said, different companies create different systems. And, we have this specific one, which is Sqlite. We chose it for these events because it's the easiest. to learn by far. Also the lightest, like it's in the name. The others are so heavy, downloading them is such a process, setting them up. So yeah. Okay. The first question is, do you have coding to connect SQL database from Python? If you're looking for code on how to connect it, it's right here. So it's on the screen. Karen is still sharing it. The one line you see where connect is equal to SQLite 3.connect to bankdb. This is it. So you have a bank.db file. This is an SQLite file. You connect to it using one line of code, and that's when you can start working with it. Okay. The question was posted. All right, so this is quite unrelated to databases, but yeah, so we have my list. It has 4 different elements. Yeah, okay, so you think the answer is 3. When you're getting the length of a list in Python, actually, so you're counting the number of elements in the list. So length is not related to the indexing. So you're counting the number of elements. And here there are 4 different elements in the list. Now you're right, the last element will have an index of 3 because we use 0 indexing format. But when we are counting them, so while C is the 0th element, O is the first, D is the second, and E is the third, but they are in total 4. So when we count them, this is what len really does, just counts them. What are the pros and cons of having a serverless relational database management system? Maybe this example will make things clear. Let's say you're having a software for a big company, and like the entire company is accessing the same data, and you have all this data that's like centralized, and the whole company is working with it. So let's say you're a finance company, you're looking at all these different finance documents or whatever. So this is obviously important to have a server where everyone's interacting with the server and taking information from the server. Meanwhile, with like SQLite, where can you use it? For example, SQLite gets packaged with your own app on your own phone. So if there's any data that's specific to you as a user, or maybe data that just belongs on your phone and not on a big server, in that case, you would use SQLite, and it would be like right there on your phone, not on a giant server somewhere in the middle of the company. All right, I hope that's clear. Okay, should I share my screen?
Yes.
Okay. You can see it, right?
You're all good.
Awesome. Okay.
Not much question, not much statement, but like I just want to compliment you guys. I did do it in a rush, the presentation. I love the fact that you guys like have like all sharp eyes and like pointed out. I came on, yes, like this is one of the stuff that I missed. Like I was like noticing. Good job, guys, to find all my mistakes. I'm happy you guys like all catching up. Like yes, and you need the parentheses. I did not close the bracket. I did not close that. I did not. Like it's supposed to have a double quote and a close bracket there. Yes, yes, yes. Good job. Good job. Good eye. Good eye. All right, Hala, do you want to start?
Yeah, sure.
Okay, I'm with myself.
Okay, so hi guys. So now what I'm going to do is I'm going to kind of maybe recap what we designed towards the end of session 1. And based on this schema that we designed, and I'll talk about what a schema is and what this whole chart that you see in front of you is. Based on this design, we're going to do some live SQL coding. All right. So what are we looking at? We're looking at a schema. A schema is basically a design for our database. We decided that we're going to create a database for a bank. And this bank has some bank accounts, it has some clients, employees, credit cards, and each of these different, let's say, components, so the 4 components being account, card, client, and employee, has its own properties and attributes. What are attributes? Attributes are things that describe a certain, let's say, a certain entity, right? So, for example, me, I'm Hala. I'm an entity. What are my attributes? My attributes are my age. They're my name. They're my height, my weight, my career goals, or my current profession, my current job. So these are all things that describe me. So when you see this chart, this square right here, you're gonna see an entity with some attributes for it. So we can take a look, for example, at bank account. This is an entity. It has 2 attributes. It has an account ID, so this is like a bank account number, you could say, and a client ID. The client ID being which client actually owns this bank account. So here, for the sake of simplicity, we assume that the client owns only one account, or actually each account is only owned by one client. So we don't have joint accounts here, but you get the point. So this is a simplified example. Obviously, banks in real life have much larger schemas with much more details, but this is our running example. Right, so we said the bank account, it stores which account ID it has, so the account number, and which client actually owns this account. And we can see this whole arrow thing over here that points the client ID in the client. Now, what is this and what does it mean? So if you were here in the first session, you can maybe remember a thing we discussed called foreign keys and primary keys. So what are these 2 different types of keys and what do they really signify? So a primary key is an identifier. It's something that identifies you, that is completely unique to you, that no other entity possesses. So let's say your car license plate, for example. Now imagine if car license plates weren't unique. And I mean like the number with the letters and everything. So imagine they're not unique. That means someone else who has the same car license plate as you gets a speeding ticket, and suddenly you have a speeding ticket because the database won't be able to understand which person, which car actually was speeding, right? So this is what we mean by having a primary key. This primary key is completely unique. It is an identifier. Without it, it's virtually impossible for us to determine who's who and what's what, right? Like your name, there's probably multiple people who have the same name as you, sometimes the same name and last name. Sometimes in some coincidences, same name, middle name, and last name. So it might get kind of difficult to identify people. So here it's really important for us to note the importance of a primary key, which is the ID, highlighted in teal in each entity. Now, the foreign key, on the other hand, the foreign key is actually related to the primary key. It basically creates a link between 2 entities. So now, what I'm saying is that, let's say this bank account, what client actually owns it? Some random number. So if I pull up a certain bank account and I say this bank account is owned by client number 453, you're just going to say, okay, this is a random number, how does this help? Exactly. This is why we have the other table. The other table would have the actual client ID plus the other information. We can see it in the example here. So, oh, actually, there it is. There's a table missing. But here we can see that, for example, we have an account. This account is account number 552. It belongs to client number 24002. All right, so this means that this account, it belongs to a woman named Jane Doe, whose age is 45, who the employee that helped her was actually Karen, because you can see it right here. So employee number 301 is the one that helped her. And this is how these foreign keys are working. it's basically like just referencing different things among different tables. And the key term being reference, because this is exactly what allows the whole foreign key dynamic to be working. Now, I hope that this is somewhat clear, especially to you guys who are joining us for the first time. I do understand that the whole concept of a schema and this, big chart that can get quite bigger, the more you add different data entities, this might be super confusing. Fear not, because we'll keep, like repeating this, we'll keep going back to it and mentioning what is even going on. And if you are interested, feel free to go back to the recording of the first session and really dive in deep. All right, so enough about the schema that we have. We saw our bank account, we saw our 4 different entities and the attributes that they have. We also are now able to understand the different links between them. What we're going to do now is basically start with some code. Now, last time I did show some sample demos, but it wasn't really in the context of explanation, more in just in the context of example to get you guys excited for today's session. So what we're going to do now, we're going to code some SQL. We're going to do it in Sql Lite. We're going to talk about what Sql Lite really is. And then after that, we're going to take off, go to Python, and write real Python code that interacts with our database. All right. So yeah, we'll be referring to the schema as we go through the demo. So before that, one thing we were talking about earlier during the break is downloading Sql Lite. So Sql Lite actually has a really nice tool called DB Browser. Now what DB Browser does, actually I'm going to show you, and no worries, I'll repeat all of this in a second. So if I open a database and I choose one, it allows me to browse my database. So here we have albums, here we have artists. This is a very popular sample database provided open source on GitHub, and it's really used to explain SQL and SQLite as well. So you can see here we have all this different information. For example, this is a table about genres, rock, jazz, metal, and all that. So this is what DB Browser does. It, like the name suggests, allows us to browse our database visually. Now, you may get away with using SQLite without DB Browser, and that's totally fine. But, while you can interact with the database, it will be hard for you to see your results and actually see the tables and everything, how it looks. So it's highly recommended that you download DB Browser. The link is right here. And you download it based on your specific OS. So in my case, for example, I have Windows. I have a 64-bit, so I would download this one and then run a typical .exe installer, like the one you're familiar with. You've probably installed tons of software this way. And yeah, it's really straightforward. All right, so that's it for actually installing SQLite. Now going back here, this is DB Browser, and I'm actually going to close this database and walk you through everything step by step all over again. So DB Browser, like we said, it's a way to visually interact and look at our database. And our database is a set of data. It's some information about certain entities or objects. And it's supposed to all make sense and be connected, right? Okay, so now what I'm going to do is I'm going to open a database. And this brings me here. So what is this? What are database files? These are .db files. So this is kainok, I'm not sure how to pronounce it honestly, or for example, sample.db. And this is the sample we actually did last time. And actually I'm going to open it. So now if I open it, I can see that this refers to the database we were talking about. I can go to database structure and I can look at my 4 tables. So I have bank account, client, credit card, and employee. So what are these? These are the tables that we had previously designed in our schema that we ended up creating. So let's go back here and verify that everything is the same. So this is it. So we have credit card, bank account, client, and employee. And these are the different tables that we have. I can actually look deeper into this. So now what I'm doing is I'm walking you through the interface of Sqlite Db Browser, so you can better understand how this interface works, how Sqlite really works. So it's a really straightforward interface, by the way. So by installing it, playing around with it, you're definitely going to have a good shot at understanding what is going on. You can actually even create another table here manually. So I can create a table, enter the table name, for example. Let's say I want a table called bank statements, right? And I can add different fields. So I can add a field called ID, and this will be a primary key, which will identify it, right? Isn't that what we said? And then I'm going to add another fee and say statement title, for example. And just no worries, I might be going fast, but this is just for the sake of example. And I choose this to be a text. So what is really happening? What's happening is I decide I want to create an extra table. I want to give it a primary key, which is an ID. So this is an identifier, something that makes a certain entity unique. So like we said, your car license plate, or maybe a social security number. These things are always unique, because if they weren't, there would be tons of confusion about different people. And a title. If I press OK, we can see now I have a fifth table called bank statements. Maybe it's in caps lock, should have maybe not done that, but yeah, this is the database structure. Now, browse data will enable us to actually look at our data. So this is the bank account table you can see right here. And then you can see the account ID and the client ID, right? And you can see that for each row, so you have an account with the number 552, and it belongs to client 24002. Account ID 553 also belongs to the same person. So it works like that. We can also see bank statements. It's empty. We just created it, but there are no rows in it. So you can also create a new record, give it an ID here. So like any random set integers, any random number, and the title. So let's say monthly statement. Okay. So what I'm doing now, why do I keep saying the word manual? Because this is stuff that I'm doing through the interface. So I'm manually inputting this, I'm working with it like it's Excel. But what we can also do is do this through actual SQL code. And this is what I'm going to demonstrate right now. Okay, so like we said, we now have these 5. And actually what I'm going to do is I'm going to delete bank statements from the database. Now it's gone. So I go here, I go to something called execute SQL. So what is this tab? What does it do? This is where we code, right? It looks like a basic editor. So here's what I'm going to do. I'm going to say create table, right? So create table bank statements, okay? And what I'm going to do is I'm going to specify the fields in it. So I'm going to say I want a statement ID, and I want this to be an integer, right? And I want a statement title, and I want it to be text. Okay, we've already decided this anyway, so this is quite straightforward. Now, what should we also do? We should also specify a primary key. And now I would say primary key, open a parenthesis, and then I would say the statement ID is the primary key, right? Okay, so now what just happened? Let's go over this statement. Let's actually explain the syntax before actually running it. So here's what we have. We're saying create table. And by the way, SQL is a lot like English. So you're very lucky because you actually get to, it's like writing natural language, it's very understandable. So you create the table, bank statements, and then what you do in that case, you add the 2 different attributes. So statement ID, which is an integer, you have to specify the data type for each attribute, right? And then you have to specify the primary key. This is absolutely necessary. You cannot have something that exists without a primary key. How can we identify people if we don't have, for example, their social security numbers? How do you go to university, get your grades, register your courses if you don't have a university ID? So you always have to be identified. And your name is never a good identifier because it can get quite repetitive. Okay, so now we've wrote our first SQL statement. Another thing we should also specify is not null. So what this does is, for example, please make sure when you're entering the values, do not enter a null value. Do not leave this blank. I want specifically a value for this attribute, but it's actually not quite important right now, so let's just go without it. So now
Hala,
what we're
sorry
Yeah.
to quick interrupting. Can you make it the screen a little bit bigger?
Yeah.
Because like
Yeah,
the
okay,
girls
I
can
should
see
make-
the statement. Thank you.
Yeah, okay, I should make the font bigger. Oh, okay, there it is. No, never mind. Just let me figure this out. Okay. Does zooming in help? If anyone's familiar with how I can like make the font bigger, please let me know. So
Is anything on the view?
I don't know.
Oh, is that able to say hello? Oh, maybe we can do that. Maybe I can just type the Control plus.
Okay. No.
Control plus, or Terry said like edit reference. So let's go to edit and then preference. Sorry.
Okay. Yeah, there we go. All right. So.
Thank you.
Okay, I can make it way bigger.
Thanks, girls.
No, you're right. Is this good? Okay, that's kind of big. Let me just make it smaller so we can actually see the entire thing. All right. Okay. So yeah, I hope this is way better now. So yeah, let me just really go over the statement again. So we want to create the table. Create table means I'm announcing that I want to create a table in my database. My database is, by the way, a collection of different tables, right? So we have one big database and inside it there's multiple tables. I decide to call the table bank statements. I can call this literally anything. So this can be virtually anything, but we chose bank statements. And then I decide to write the attributes that it has. So it has an attribute statement ID, which is an integer, and a statement title, which is text, and a primary key, meaning that statement ID will be identifying it. So now what I'm going to do is actually run my first SQL statement. So I press run here, and here's what it says. It says query executed successfully. It took 2 milliseconds, okay, and then there was a table that was created. Going back to database structure, we can see bank statements here, and that it has a statement ID, this is the key, and the statement title. So we successfully created it. We can go back and go to bank statements. Again, we see it's completely empty. We can manually create a new record. Let's give this statement ID something. Okay, and a title, let's say monthly or whatever. Okay, so we just added a record manually. How can I actually add a record not manually? So let me actually add it through the code. Now I'm gonna just cut this because I'm gonna use it later and add some actual values. So we say insert into bank statements. Okay, statements values. Okay, no. Bank statements, we want the statement ID and we also want the statement title. So here I'm telling SQL, this is what I'm inserting into bank statements. And what am I inserting? Values 2445 and something weekly statement or something like that. Okay, and now I highlight this, I run it, and the query was executed successfully. Going back here, we can see we now have a second row. So now this was obviously erased before. Anyways, we now have a second row in the table, and you can do this infinitely. So you can continue to add and insert data into your database. I hope so far everything is clear. Like if there's any questions, I would love to take them up now at like this point. So let me know, guys, because I can't see the chat.
No questions at the moment.
What? No, no?
No questions at the moment.
Okay, great. Awesome. All right, so now we know how to insert. So we can also do this for like multiple values and then just like, you know, keep running this and inserting more statements. So we can see that here. Now we said this statement ID, it's a primary key and it's an identifier. Now what's going to happen if I try to insert another row with the same statement ID? We said it's unique, it cannot be the same. So we want 2445. So now I'm going to add 2445 and run it. Obviously we get a big red square and it's telling us that unique constraint failed. So this is a constraint. This means that SQL will not allow you to do it. You're not even allowed to even think about it. Don't even try it. This will not work. It will break your code. And this means that you cannot add two different statements with the same ID. So you cannot register two cars with the same license plate. Think of it like that. So yeah, this is definitely wrong. Now, another thing, like earlier, we were doing this create table thing. Actually, let me erase this. Okay, so we were running create table. Now, what happens if I run this twice? So I already have a table called bank statements. I want to run this a second time. Another error. Result, table bank statements already exists. Okay, so now we come to this question. Like, you're obviously going to be writing code for a big app, there's a big database. You can't always know if there is already a table called bank statements. What do you do in this case? You do the following. So create table if not exists bank statements. And now if I run this, it's successful. Everything worked out. We actually managed to run it, but nothing new was created. So we're still in the same everything. So what does this mean? This means that this if not exists statement can really get you out of tons of headaches and bugs and errors. It's good practice to always have it, to make sure that if this table doesn't already exist, I will create one. And remember when I said it sounds a lot like English? Because it does. So create table if it does not exist. Okay, so I hope that's clear. So we said we're covering CRUD applications, so create, read, update, and delete. This is create. You're now able to create tables through code. What you have left to do in this case is tons of practice. So I want to create another table. What I go ahead and do is, okay, so I create table. I want to call this one, let's say bank managers. I'm totally guessing at this point with bank stuff. And this will have things like manager ID, which is an integer. It's gonna have the manager name, which is text, for example, the manager age, which is also an integer, and so on. So this is all depending on how you choose to design your data. Like we spoke about how we design our data. Actually, what we do is we look for the necessary attributes that we need. What specific information do I need to store about this specific entity? And finally, we announce a primary key. And when we announce a primary key, we say the primary key is the manager ID. Okay? So yeah, this is how we can create another table. Now we can also run this, obviously, and we have an error, incomplete input. So I should have closed this. Here we go. And now it worked. So database, I can see here bank managers, and we can see the different things that we created. Manager ID, manager name, and a manager age. Okay, so really that's really it for creating. Now, another thing we can do is do this through Python. So we said this is a woman who code Python track, and I want to do these through Python. So we go here to VS Code, for example, or any text editor that you choose. And really, I can even erase this stuff for now, but all right. So Karen already covered this, that we must import Sqlite 3. So this is actually built into Python. You do not need to actually install or use pip or anything. The next thing you do, you connect to your database. In our case, this is the kinok.db fold file. And then you use a cursor and you connect it to this cursor. And the cursor will be executing all these statements. So we would say cur.execute, and here you would paste an SQL statement. So for example, I want to create a table as well, but let's not even paste anything. Let's just type it here. So create table. Okay, I'm gonna call this table branch for different branches of this bank. And what I'm gonna do is I'm gonna give it some attributes. So a branch ID, which is an integer, and a manager, right? And this manager will be related to the other manager, but for now, let's just keep it as a manager ID with an integer. And then I can announce a primary key being the branch ID. Now, one thing I kind of want to highlight as well is that this stuff here is like purely SQL syntax. So this is stuff you'll only get used to with practice and with time. So knowing when to open a parenthesis, when, like how to actually declare the primary key, whether primary and key are actually one or two words. This stuff is actually just habit. It will come to you later. All you need to know is actually understanding this structure of these queries, and then you can just follow it and really always continue to use the syntax until you don't have to actually look at it. Okay, so now I can run this. So what I want is to create a table branch, and this table will be be created in the database. Now, one thing I am actually like noticing just now is that I have a different this is linked to a different path. Now, what I'm going to do is actually get the specific path for this and make sure we're talking to the same database. And I'll clarify in a second. So I'm just gonna get the path. Just give me a second. Okay. And yeah, now what do I mean by this? I mean that there is a version of this kind of database on my desktop, which is the one that I have open in SQL Lite. That's literally all I'm trying to ensure. Okay, so now we're ready. We can officially run this. Okay, we have an header. Let me see. Okay, I think it's actually quickly these. Yeah. Okay, here we go. Okay, done. The code was successfully run. So now what we have to do is go back to our DB browser and see if a table branch was actually created. So here, database structure, and okay, so it's not. Oh, this is the sample DB. Okay, I confused. So I put kinok. So this should be sample, my bad. And now we run it. Okay, and now just please tell me. Did we run it? Oh no, there's an error. Table branch already exists, which means this should be working fine. What I'm going to do is I'm going to open the database again. Save. All right. Sorry, guys, I'm just having an unexpected error. I'm just trying to show you how. Okay. So we said in sample.tk. Okay. and we're not getting the branch. Okay.
Maybe create a branch too, like just for the convenience, like name your table branch too.
Yeah.
Would that be?
But it's still not showing up. Okay. Right. So it's supposed to show up, but it's not. So I don't know if it's the path, it's the wrong one. So here's what I'm gonna do. Just hold on a second. I'm just gonna ditch this altogether. Okay. I'm really sorry, guys, for the confusion. It's just, here we go. Okay, so now I have this other database open, which is the Kynoch database, and it has these 13 tables, as well as all this different information. What we want to do is to actually insert a table called branch. So this is what we're trying to do. And to do that, we're just going to actually run our Python code, and it should end. Okay, so this was supposed to be working. I'm not sure what's going on. Right, but anyways, so you get the idea. Okay, so basically, okay, let me try this. Never mind. Okay, so basically what's supposed to happen is we're supposed to get an inserted table called the branch into the database. Now we're not actually seeing it. I'm not exactly sure why, because this is actually supposed to be working, because it was working. Yeah, so I'm assuming it's confusion with like the different files and folders that we have.
I think in the place of connection object, try cur cursor.execute and the line, if you could, and the line 7, cur.execute.
Here?
Yeah, cur.
What do you mean?
If you remove the conn object and if you put cur object.
Okay, so cursor.execute.
Yeah, if you execute this one.
Yeah, that was what I was doing before, honestly, but then okay, so let me see again. So I believe we're getting an error that branch2 already exists, even though we can't really see it here. This is, so it's getting created, but we can't really see it, which is the part that's confusing, right? There it is. Okay, so there's branch2. We just have to reopen it. So sorry
there
for
we
the
go. Yay.
Okay. Really sorry for the confusion, guys, but what was happening is it was being created, but it's not like automatically refreshing, so we had to just open it all over again. So let's backtrack a bit and just repeat what just happened and really explain what's going on. So basically, this is the procedure for taking those SQL statements that we were writing here. So here we were writing stuff in this line, we're creating tables. We would say create table, give it a name, specify the value, specify the primary key. And then what would happen is the table would actually get created. So this is the Python equivalent. You have a Python code, you use it to import Sql Lite 3, you connect it to the database, and then what you did is you executed and created the new table. So we saw that branch2 was actually created. So yeah, this is how we were able to actually create a new table through the Python code. I hope this is clear. We should stop for questions because I feel like some confusion was brought up with like the whole thing that was happening. But yeah, please let us know if you have any questions. Let's say this is the first part of our CRUD applications, create, read, update, and delete. So this is create. Yeah, so any questions?
No questions.
Okay. All right. So yeah, the next thing is actually reading. And reading is actually quite the most important or most interesting part of SQL, you could say. So how does reading actually work? So the way reading works is that we use a select statement. Select statement will actually select stuff from the existing tables that we have. So like I said, this is the Kinok sample database. So here we have a bunch of albums, some artists, right? So here the albums, let's say I want to select, or for example, yeah, I want to select all the albums who have an artist ID of 2. So the same artist made them. What I would do is I would select star from albums where artist ID is equal to 2. And I run this. And I get these two different results. So I get Boss of the Wall and Restless and Wild. And these two have an artist ID of 2. Browsing our data, we can see all the others have different artist IDs. So how does this select stuff really work and what is going on? So again, we have the select. What it does is it's basically selecting. It's producing an output table. So just like the tables we have, it's producing an output table. When we put star, we say we're getting all the columns. Okay, we'll go back to the star in a second. From albums, so from table name, where the specific attribute is equal to something. So where the artist ID is equal to 2, get me those. And now what does the star do? The star gets all the existing columns. So album ID, title, and artist ID. If I only want one of them, what I have to do in this case, I would, for example, I only want to see the title. I run it. So here I get the titles of the albums where the artist ID is equal to 2. So here, the queries, the select stuff, this is the big stuff in SQL. This is where it gets complex. This is where it becomes powerful. So now I want the titles from the albums where the artist ID is equal to 2. But let's say I actually don't know an artist ID. I just want to get those by, for example, ACDC. So how do I do those without knowing that their artist ID is actually 1? So here's what I would say. So let's say again, select star from albums and artists, because I'm using 2 tables here. And now what I want is I want the name of the artist, where artist dot name is equal to ACDC, and the albums dot artist ID is equal to artist dot is it ID? Artist ID as well. Okay. And this is where it's definitely confusing. So I'm gonna run it. I'm gonna show you the result, and let's see. No such column artist dot name. Artists, yes. Okay. And I'm gonna explain exactly what's going on. Okay. So here's what we get. We get that this album, For Those About to Rock, We Salute You, Let There Be Rock. You know, we see here that we get these 2, which are for ACDC. So what does this query actually mean? I'm saying select everything from these 2 different tables, the albums and the artists, where the artist name is ACDC, right? Now, what does this part here mean? Let's say I run it without this part. So I run it like that. I would get everything from all the albums, and then it will just combine it with the artist ID and name, even though here the 2 artist IDs are not equal. So what does this mean? It's like, this is where SQL is confused. Like, you just want me to combine these 2, right? Okay, not really. So this is the actual correct syntax. So we're saying only when they're equal, when this specific album is referring to the exact artist, only when they're equal, get me where the artist name is ACDC. Okay, let's actually stop for questions for a second. Any questions?
I think we're good.
Okay, great. Okay, so I try not to take too much more of your time because I know we're like constrained. We had like an issue, but yeah. So I hope this is clear. So this is actually the query, right? And you can do this in a variety of ways. So for example, you can go to invoices. And let's say you want to see all the invoices sorted by their total. So now what I would say is I would select everything from invoices, right? Order by total. Okay, so I'm ordering them by the total because here they're all messy. And now I would run this again. And now if I go here, you can see the total starts at 99 and then it goes up and it's ordered ascending. You can also say descending and run it. So now it starts by the highest one and it goes lower and lower. Okay, so this is like different things you can do with SQL. Also, another thing you can do, you can limit. So I want to limit to the top 10. What if I have a database of millions of entries? You obviously want to limit it. So now I run it, I get to see the top 10 results. Okay, so this is just syntax. It helps to memorize it. At first, you're going to start by maybe making a cheat sheet. This is what I would do, like maybe just, writing them down, their statements, how to use them, and referring to them every time you need one. And then at some point, you're going to stop looking at this sheet and you're going to think, okay, I know how to get this. Okay.
Camera has a
yeah.
Sorry. Camera has a question about ACDC. So if you're gonna read it at the chat, maybe before you go to the next part.
Okay, in the chat or the Q&A?
On the chat, yeah.
Okay, why can't I?
Thank you.
Yeah, why does ACDC show up as the artist even when you search it without? Yeah, this is actually, I'm gonna try to undo and go back to that. Here, if I run this, so this is what the question is referring to. Okay, so if I run it without this, ACDC will show up as an artist for everything, even though this is exactly not true, right? So what's happening here is, this is how SQL will read this. It will say, select everything from these two tables, right? But it's only filtering the second table in the case that we only want the artist name to be ACDC. But what it's not doing is it's not checking if it's the same artist. It's not verifying whether the artist ID and the artist ID are the exact same. So actually, maybe it will be more clear if I even remove this as well. And now if I run it, what will happen? You will see that for every song, every album, you will see all the artists. So this is like, it's combining them, you could say. So for this album, you can see it with AC/DC, with Accept, with Aerosmith, with everyone. And you scroll down, for the next album, it's also with all of the different artists. So it's like, it's a way of combining them. It's like if you have, 10 albums and 10 artists, it's just going to show every single album of every single artist. This is how SQL will understand it. But we specify these conditions to make sure that it will understand it in the way we want. And okay, what's my error now? Let me. No such column. Yeah, it was artists here. Okay. And now if I run it, this is the correct answer. So I hope that answers your question. This is how in practice we will do it. Whenever there's a foreign key, to make sure that the linking is correct, we verify that the two have correct. They're both equal. Okay. I hope that helps. All right. Okay, so moving on, I guess. So the next thing would be, we did read. The next thing we want to do is actually to update and to delete. But before that, let's actually try to execute the same statement from here, from Python. So this time, I'm actually going to delete this stuff. what we're gonna do is the following. So I'm gonna uncomment this out and explain this code. Now we write the SQL statement here. And should I escape these? No, okay. All right. So what are we doing? We pasted the exact same SQL statement, and then for row in cursor.execute this statement, we want to print this row. So now I save and I run. Okay, you can see here that they were both printed. So you can see that this was the ID, this was the album name, and then this is the artist being AC/DC. So the same results that we got here, we were able to print them in Python. So this is enough to say that Python with SQLite is pretty straightforward. Understanding the SQL part and writing the queries in SQL really leads you to just easily put them in Python, simply by making sure that cursor.execute this statement and you're done. Okay, so this is really straightforward. So I'll continue in SQLite. We did create, we did read. The next thing would be to update. So for example, I have the invoices here. So what I want to do is that I want to update all the ones with the billing country being USA to United States. So I decide to change this internally in my database. So what I would say is I would update invoices. So you put the name of the table now. And then in this case, what do I want to do? I want to set, okay, I'm gonna set the billing country to be equal to United States, where it actually was before equal to USA. Okay, so the where part is quite similar to the one we're doing in the select. So where the billing country is equal to USA, I want to set it to United States. Now I run it. What's going to happen now? I go back to my browse data. You can see here you have United States, and these were all USA before. And you can obviously change it back by doing the opposite. So I'm going to change it from where it is United States. Okay, that's it for updating. It's quite straightforward. You have a where statement, and it shows you that where billing country is United States, I want to update by setting it to something else. Okay, and now the last thing is deleting. Deleting is also quite straightforward. Now, obviously removing all this, I want to delete all the ones with billing country equal to USA. So delete from invoices where billing country is equal to USA. And now if you run it, okay, foreign key constraint failed. This is actually like another problem, but basically it's related to the foreign key because it's actually linked to other things, the invoice. But what you can do is, for example, invoice items. Let's say we want to delete all those that have a unit price of 0.99. Okay, so from invoice item, and I'll explain what happened in a second. Unit price, and it's equal to 0.99. And now if I run it, it was successfully done. We go back to browse data, and you can see the next unit price is 1.99 because we deleted all those that only cost 99 cents. The reason before we had an error is because of foreign key stuff, where this is actually linked to the other one, which means that if you delete all the invoices, you actually have to delete their corresponding rows and invoice items. I hope that makes sense. So yeah, that's it for some basic SQL. I hope it was useful, and I hope you were able to understand it and see that you can take the next step in SQLite. Please let us know if you have any questions. So let's open it up for questions right now. Any questions? You're welcome. I see a question actually. Is it the same process for other relational databases? The SQL part, it's almost the exact same actually. You can't get away with knowing one type of SQL and really putting it everywhere. The procedure of actually connecting it to Python is different. It's different for every database. But yeah, the SQL part remains consistent. Yes, and there are two more events. So yes, thank you, Stephanie. The two events are actually not SQL related. There are no SQL databases, but we hope to see you there regardless for more database information. Okay, I guess I can stop sharing.
So Materi has a question. So is there a way to limit the amount of RAM Sqlite uses on your machine?
Oh, okay, interesting question. I don't believe SQL Lite uses tons of RAM. It's actually quite, conservative given that it's serverless and it's, just some basic data, like that's inserted in a table. But it's actually a good question. I'm not 100% on the answer because I don't know. I've never done it. But yeah, I think we can maybe look into that and see, try to help you out. So, is there a way to limit RAM for SQLite? Okay, so there are ways to set memory usage. So you would allocate some limit to SQLite, and SQLite will make sure to stay below this limit. And to do so, there is a function called SQLite 3 soft heap limit 64. So it's actually quite straightforward. It's just one Google search away. Okay.
Maybe we can wait for 2 more minutes for any last question in case they're typing.
Of course. And you're welcome, guys. Thank you so much for joining. We're so happy to have you here. Yeah, you close the connection at the end, the very last line. Yes, the recording will be up on YouTube. Also, if you registered for this session, I believe you get a link to the recording. So, yeah. Okay, so favorite SQL practice environments. If you want to do something online, I would say maybe, let me check if they actually have SQL. So REPL usually is a good online text editor. Yeah, here, okay, I'll send you the link. Okay, so I've used this for other languages, so things like Python and Java, but it's actually really good and it does have SQL practice. So check it out. And in case you don't want to make the commitment of downloading something. But also, SQLite is pretty light. So if you do choose to install it, it's straightforward and not very heavy.
Camilla asked a question. Can we read table as data frames in Python? Yes, but I haven't tried it.
Yeah, so Ramya actually answered it in the chat that you can read data frames with pandas. So yeah, pandas is quite popular in like data science. But you know, like I'm sure there's a way for you to be able to take your SQLite data and convert it to a data frame. But automatically read it, no. So no, you're actually reading it using the cursor, and that's a specific mechanism.
Guys,
Okay.
just one quick thing. So in case some of you is new and wondering why we're doing the exact same statement on both an SQLite browser and a Python, like do the repetitive steps. That is because there are a lot of things that we build on. For example, an application, you need to touch in, like, for example, if you heard about the framework Django or Flask, you need to interact with both front end and the back end, and the back end including the database itself. So there are some there, if using Python building the app is actually way more convenient to just do the statement there instead of like going to an SQLite and then type the browser and then convert it. So that is the nice thing about doing SQL statements in Python. Just a FYI, if you're wondering like why are we doing this.
Yeah, definitely. Okay, so any more questions?
Maybe all good. I think everybody is good. I think I don't have questions.
Awesome.
Sandra, no, the repo link would not be would not be in the email, unfortunately. If you're in the Slack, as I think Stephanie posted the Slack invitation. If you want to join in the Slack group, we make sure, like, you know, you can access that, you can find the information there, and the GitHub, the repo it will be on the Woman Who Code GitHub link. It's not available yet, so that's why you can find it anywhere. But we will post it like soon after the session.
Okay. Yep. Also, I think it will be in the caption of the recording, but I could be mistaken.
Oh, okay.
Okay. Thank you guys again.
Thank you. Okay, thank you for staying up for us.
Good night.
Good night. Have a good day. Have a good evening, guys.
Thank you all. Thank you.
Thank you guys.
I'm glad you guys had a great time. Come back for next section.
Yeah.
Okay. Bye, everyone.